Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem closest neighbor in BST. So the problem says that we'll be given a binary search tree. And in this particular binary search tree, we are given a number n. And we have to find the greatest value in this particular binary search tree, which is less than or equal to n. For example, suppose that if the n value was given as 24, so which value is there inside this particular given BST which is less than equal to 24? The greatest value that is less than equal to 24. So that is nothing but 21, because 21 is less than equal to 24 and 21 is the greatest value that is less than equal to 24. Okay. Now similarly, suppose that if the n value was given as 4. So if the n value was 4, then for 4, which is the greatest value inside this BST that is less than equal to 4, that is nothing but 3, because 3 is less than equal to 4. Okay, so let us try and check when the n value is 4, then what will be the approach here. So when the n value is given as 4, so currently we will start from where? Like you can say that currently we will start from the root node, that is from 5, and when we are at the current node, so we will check. So we will check that what is the value of the current node, what is the data of the current node with respect to n. So currently we see that 5 is greater than 4. If 5 is greater than 4, so I'm looking for element which is less than equal to 4. So if the current node that I'm at, if it is greater than 4, so then I want to go to a lesser element. And in BST, you know that whenever we are at a particular node, so if we go on the right, the value increases. If we go on the left of that node, so the value decreases, because the left child is less than the current and the right child of the current is having value greater than the current. Okay, so since we are at the current node and the current node is greater than n, that is 4, so we need to go on the left. So we'll go on the left, and now we will go where? We'll go, the current node will now be 2. Now if you go to the node 2, so basically you can observe that the current node is 2 and 2 is less than equal to 4. So since 2 is satisfying the criteria, so I'll not directly return the answer, because I don't want the node which is having value less than equal to n. I want the greatest node which is having value less than equal to n. So what I will do is, as of now, the current data that is there, I'll store it. So I'll store 2, and now since I want the greatest value that is less than equal to 4, so if the current data is less than equal to n and I want the greatest value that is less than equal to n, so I'll go on the right of current, because I want to increase the current value. So we will go where? The current will go to the node 3. So now the current is at 3. Is 3 less than equal to 4? Yes. So we'll update our answer with the current data, and current is now 3. So answer gets updated to 3, because 3 is also less than equal to 4. And you can see that our answer has increased, right? And we want the greatest value that is less than equal to 4. Now what will happen is, when we are at the current node, so since it is less than equal to 4, so we again go on the right. The moment we go on the right of 3, so we encounter null. So that is when we stop, because the current should not be null. And you can see finally we have stored 3, which is the greatest value that is less than equal to 4 in this particular given BST. Let's do the same dry run for the test case where the tree is same but the n value is given as 24. So suppose if the n value is given as 24, then what should we do? So if the n value was given as 24, then we will start from the current node. The current node will be 5, and 5 is having value less than equal to 24. So that is why you will say that inside your answer you will store the answer as 5. That is the value of the current node, and then we want to increase our answer. So we will move on the right. So the current moves to 12 now. So the value 12 is also less than equal to 24. So we'll update the answer with 12 here. Then after this, again this is less than equal to, so we can say that we want to increase our current answer. So we'll go on the right child, because the right child will be greater than the current. So the current goes to 21, the right child will be greater than 12. So now we go to 21. Is 21 less than equal to 24? Yes. So we update our answer with the current data. So the current is 21, so answer increases, you can see. Now after this, since it is still less than equal to, so we go on the right child. So we go to 25. Now is 25 less than equal to 24? No. So if it is not, then we then the moment the current reaches 25, so since the current value is greater than 24, since the current value is greater than the given value n, so we need to go on the left now, because we want to decrease the value. So the moment we go to the left, so the current becomes null, and that is when we stop. And the answer is storing what? The answer is storing the value as 21, and 21 was the greatest value that is less than equal to the given value n, that is 24. So I hope that you have understood this approach, that whenever we are at a particular current node, so if the current node value is greater than n, then we need to decrease the current. Okay, so we'll go on the left. Otherwise, if the current node value is less than equal to n, then we'll store it as our answer, we'll update it as our answer, and then we move on to the right to find the greatest value that is less than equal to n. Okay, I hope that you have understood this idea. Now the time complexity of would be what? If the tree is skewed in nature, so the time complexity would be nothing but order of n. Am I taking any extra data structure or any extra recursive space? No, because we are just going to simply iterate, deciding whether we are going on the left or the right. So the space complexity will be constant, that is order of 1 for this problem. This problem has been asked in companies like Microsoft and Amazon, and it is regularly repeated in a lot of companies. So let's try and implement the code for this particular problem as well. So what I need to do here is, firstly, question also says that if suppose that there is no node inside the tree which is having value less than equal to n, then you need to return your answer as -1. So initially we'll mark our answer as -1. Then what we will do here is, we will update the current node with the root node, and then while the current node is not equal to null, till that point of time we'll iterate. And what we are going to check is that if the current node that we are at, if its data is less than equal to n, then we can say that answer will get updated to the current node's data, and then we will do what? We will move our current node to the right, because once we have stored this, so we want a greater value, because we want the greatest value that is less than equal to n. So if the current node satisfied, then we'll try to increase the value, so we'll go on the right. Otherwise, if the current value is greater than n, so this means that we need to decrease the current, so we'll go on the left of current, because the left will be lesser in a BST. So we'll go to the currents left, and when the traversal will be over, whenever the current reaches null, so then at the end of the day we can simply return the answer variable that is going to store the final answer. Let's try and compile this to check if our code is getting accepted or not on the sample test cases. So yes, I have made a mistake, that is current. So let me check what is the issue here. Okay, problem basically says that there is some issue with node. Let me just try to see what is the issue. Current data, struct node, no member data. So I think it might be having the member as value. Let's check. No, it has the value, like basically the data is represented by key. So we'll write key here, and instead of data we'll write key here as well, because if you'll see in the definition, so you can see that the node left, right, and key, instead of data they have given key, so we need to use key here. Okay, so the naming is different here. Let's compile it again. It is giving the right answer. For 24 it is giving the answer as 21. Let's submit this to check if it is getting accepted or not. And you can clearly see that our code was able to pass all the test cases. I hope that you have understood this problem clearly. Please make sure to comment understood, and thank you for watching this video. Keep coding.